Hello, everyone, and welcome to today's SANS webcast, Network Security in the Cloud, sponsored by Accurix and For All Secure. My name is Carol Auth of SANS. Today's featured speakers are Jim Bird, SANS Analyst, Eric Johnson, Senior SANS Instructor, David Brumley, Co-founder and CEO For All Secure, and Piyush Sharma, Co-founder and CEO of Accurix. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Thank you, Carol. We are very much looking forward to the second webcast on our survey on rethinking the Sec and DevSecOps. The topic of discussion this year is all about security as code. And in this webcast, we're really excited to introduce our panel instead of just Jim and I this week. If we take a look at the next slide, we'll go ahead and introduce our group here. I'm Eric Johnson. I was on the discussion last week with Jim Bird, so you probably already know who I am. I'll go ahead and pass it over to you, Jim, if you want to do a quick introduction.
Sure, I'm an analyst with SANS. I'm a recently retired CTO of a major global financial trading platform, working with SANS and with OWASP for the last 10 or 12 years, and author of a couple of books on Agile security and secure DevOps for O'Reilly.
Excellent. David, go ahead and introduce yourself, our first panelist.
Hey, my name is David Brumley. I was a professor at Carnegie Mellon University where I got very interested in this question of how do we do fully autonomous AppSec? And we built a bot called Mayhem that entered something called the DARPA Cyber Grand Challenge to show whether or not you could do fully autonomous cyber, and we ended up winning it. And so we've been working hard to productize it and bring it to the world. On the side, one of the things I'm really proud of is I help nurture hacking teams. And so one of my hacking teams, PPP, will be at DEF CON this year. So if you're going to DEF CON, please root them on.
Excellent, thank you. Our other panelist, Piyush Sharma, go ahead and introduce yourself for us.
Thank you, Eric. My name is Piyush. I'm co-founder and CEO of Accurix. Accurix is one of the first companies started the shift left motion, the true shift left, which is immutable security for immutable infrastructure. I've been in cybersecurity for 15 years. I started my career as a research scientist on cybersecurity encryption endpoint, and built and led a few major cybersecurity threat investigation incidents in the past, and that's what brings me here.
All right. Well, we look forward to picking your brains a little bit about some of the numbers that we got back in the survey. Before we jump into that, I'll go ahead and pass it over to Jim, and Jim can introduce us to the survey and what our goals for the year was.
This was, I think, our 9th survey that's focusing on either AppSec or DevOps security. And as Eric mentioned, the focus for this year was we wanted to look at security as code. So the role of coding in security and the role of security in code. What does this mean to organizations? What does this mean to developers? What does this mean to security professionals? From a perspective of training and skills, for tooling and technology, and for your priorities and goals. So if you want to watch the webcast of where we focused on the results of the survey, you can go to that link. There's 4 different sections that we're going to be taking a look at here. One is the cloud as code, so around cloud platforms and platforming. Another one is around configuration management, where we start taking a look at building particular types of runtime architectures in code and managing them. We're going to look at continuous integration and continuous delivery, the pipeline for delivering changes in code, and then finally we'll take a look at some of the future issues and challenges that organizations are facing. So Eric.
All right, the cloud is code. This is one of my favorite topics just because it's so cool how much you can do with some of these configuration languages out there. On the next slide, the very first statistic that we've got is all about velocity. And Jim, I think we've been tracking this one since the very beginning of this discussion. And as we've seen these organizations go from making quarterly releases to monthly releases to bi-weekly, and some of them are even going as far as delivering features, every day through automation. So we've been looking at this for a while, and we've now got 75% of our respondents delivering changes to production more than once a month, which most of the respondents, I would say, come from an enterprise background, which was typically the slowest, the silos and change approval boards and having to deal with some of those idle processes and things like that. Over the last 5 years, 14% increase just in velocity overall. So our first panel question, we're going to jump right into it here. And David, I'll start with you. Is with velocity continuing to increase, I'm not seeing this stopping or slowing down anytime soon, we would expect to see test automation kind of going right along with that. And if you dig into the white paper a little bit, only 29% of our respondents are saying that they're fully automating security testing, inside of these delivery pipelines. So starting with you, what do you think is holding that back? What tools and techniques should people know about to maybe be more effective in this high velocity world?
I think this is a really interesting question. So first, I think it's the right type of question. For a long time, we used to treat security really as a bit. It was either secure or not secure. And the way I think that we become more effective is we actually start thinking about security as velocity. The goal is to move faster than the attacker. Once a flaw is identified, you want to get out that fix faster than the attacker. So it's not just about features, it's also about how we can react as things evolve. So I think that's a big part of it. First, fabulous question. The second is, it's actually really difficult right now with a lot of the kind of pre-shift left tools to fully automate them. And that's for a number of different reasons. And part of this, by the way, was actually studied in the DARPA Cyber Grand Challenge. There, the goal was to completely automate finding and fixing flaws and getting them fielded so that you were just more secure, but you kept performance and functionality and uptime up. And so I think there's a couple things. First, people are kind of looking at old techniques and saying, okay, I'm just going to put them in my DevOps pipeline and try to automate them. But you have to pick the right tool for the job. Some things are going to be better to automate than others. I think one thing is, first, you got to look, of course, at the language and the culture, right? There's a funny statistics if you go to JetBrains where like the #1 response for C++ developers on, do you test is like, what tests? I don't use a testing framework. I don't even test. But when you get into like the Pythons and the JavaScripts and the Java, you see a lot more of that. So I think when you're talking about security testing, you have to first look at the language and pick the right tools for the job. But the second is going and looking at the techniques that you want to take. Things like, scanning a container are super easy to do, and you can get those started right away, and that's a great place to start. But then when you start going to more thorough techniques such as static application security testing, what I found interesting is it was kind of rated high on the survey, but people are showing it's really hard to automate. And certainly you can like automate the test running, but you still have to manually look at the results. And I'm a big believer that actually if you have really any false positives, it's going to be harder and harder to automate things. And so I think what was interesting in this survey is you actually saw an uptick in dynamic analysis. And at For All Secure, we're a big believer in things like fuzzing to help. And it's kind of funny when you look at DARPA spent $60 million studying this problem, every single one of them used fuzzing and 0 of them used static analysis. And that's because you have 0 false positives. So I think to answer the question, one thing holding it back is just maturity level. People have to first build containers and get things in containers. That's the first thing. The second thing is you have to look at what is the right tool for the job. And when you're looking at fully automating your security testing, you have to pick something that's automatable and not just, for example, automating a checklist that then a human has to review before you can actually deploy. And so I think you want to look at the sort of techniques. And like I say, like you can make your choice. At For All Secure, we're just big believers in fuzzing. And I think people like Google have made similar choices, but it'll be dependent on your culture.
Excellent point. Yeah.
Piyush, what do you have to add to that? What do you think?
No, and I concur what David also said, but I'll take a bottoms-up approach here. Like to share some anecdotal data that that will explain why this is so critical. So your architecture have changed. We have moved from monolith to cloud workloads, VMs, and now we're moving to container workspace. So your architecture, typical architecture is multiple layers. You have network, compute, storage. You have Kubernetes. You have serverless. You have service mesh, and so on and so forth. So what is happening is in the cloud, especially, you have multiple control planes where you are actually defining your configuration, and sometimes you're defining without automation, which means that you are going to those control planes and defining those configurations, or you are declaratively defining, which is something we call infrastructure automation. Now, what happens is there are multiple control planes, and there are multiple ways infrastructure can be configured in different places. So it's a typical multiple attack surface issue where your attack surface is now pretty scattered across multiple control planes. How do you bring it together? And that is why automation is so critical, that when you start declaratively define your infrastructure, say for example, where your containers are running, what kind of compute that they're running, and what their network configurations that they have, what kind of exposure they will have, and what application is running on those. So it's all contextual, and it coming from different places, different Scrum teams, different DevOps team provisioning it. So you might have a platform team who's managing Kubernetes infrastructure, but then you have your application team who's just focusing on application builds. But at the end, it all comes together. It all comes together in runtime, and when it comes to runtime, you already exposed, which means that infrastructure is available. Every vulnerability that you have or running with is already available. So what is the right way to do it is you have to automate your security testing. You have to embed, you have to start when your DevOps or developers start to define your infrastructure, whether it is declarative, whether it is through pipeline, the commit or build stage, or you're doing in runtime. Runtime is too late. It is too late. You have to do it sooner. That's my assessment of the first question, and I'll keep it very basic, ground up, which is the second part is what is holding back automation. I think holding back automation, like David also alluded to, is two things. One is maturity of your teams, as well as maturity of architectures. If you have moved to cloud native world, or you still on the old monolith application architecture, you have constraints in terms of how much you can automate. And that is the bottleneck, because every time you deploy or you create new versions of your softwares or products, you have to bring multiple pipelines together and then deploy. Whereas in the cloud world, it is very different. It is high velocity, but it is asynchronous, and you deploy whenever you want. In the ephemeral world, which is like containers, and that's what we keep calling immutable infrastructure, is where infrastructure is never patched, or you do not fix infrastructure in runtime, you always rip and replace. So it's maturity of the organizations, and it's also maturity for your architectures.
I think that makes
great responses there. I mean,
I think
what do
that
you
would
think?
make sense. I would just like add on a little bit that even if you have an immutable architecture, you have to do the testing somewhere. Like when you're building the new Docker image, you're going to have to run your automated tests. So I think that's just a key part, is you got to focus on what are the right tools for automating those tests, whether it's in the deploy or the build phase. And then, as GitHub would recommend, run them for a little bit. Don't try to gatekeep right away. So don't try to do too much right away. And then later on, as you learn what's working for you, then try to do things like gatekeep.
Excellent. Well, that alludes to our next couple of statistics here as we look at, infrastructure as code came up a few times there, and the ability to collaborate across teams as well. Because you've got, as we mentioned, the infrastructure team, you've got the DevOps team, you might have a development team, your testing team, your security team. They've all got to work together in this ecosystem in order for automation to be possible. So as we look at just that complexity, and then you start to bring in multiple public cloud providers that are hosting these infrastructures, which are full-time jobs for teams of people by themselves. And now you're going to bring in more than one or two, or as our survey pointed out, 57% of these orgs have 3 or more already. So you're even including, some Alibaba, some IBM, some Oracle Cloud, et cetera. Things are complex. So the security impact of doing this, I don't think anyone would argue is tremendous, because now our security teams have to know all of these different things. And if you flip to the next slide, Jim, we then look at the increase in cloud security focus, which makes sense to us because we're onboarding all these new clouds. Now you've got security teams spending 63% of at least half of their time on public cloud security, which is a huge increase from last year. So at least security is trying to catch up a little bit. And then if we take a look at the next statistic, this is where I think there's a bit of a disconnect, because we've got 60-something% of security folks focusing on cloud security, but only 34% of these orgs are actually working on that automation piece where we're automating the cloud infrastructure. So to me, it shows a little bit of kind of the same story, where we've got a lot of this work going on, but we're not automating our security testing, and just the same as we're not automating the invocation of cloud APIs to build and provision resources. So if we take a look at our next panel question, given what we've already talked about, increasing velocity, what do you think is holding back the adoption of infrastructure as code that enables a lot of cool security tooling and automation to be used in just cloud infrastructure space? So Piyush, I'll start with you on this one. What do you think about this question and the lack of adoption on the infra as cloud code?
So, infrastructure as code has been growing exponentially since last 2 years, and one of the data point is the growth of Terraform as infrastructure as code, or growth of Kubernetes manifest, or package tools like Helm charts and Kustomize. And why is it happening is because your infrastructure is getting very, very complex. It has hundreds and thousands of resources, components. It is impossible for a human or set of humans to always monitor, observe, and make the configuration at runtime, because changing things at runtime will have its own repercussion. It does not allow you to do any kind of testing, like David was also saying. So the first thing that infrastructure as code allows you to do is define everything declaratively in a static world. You are able to visualize that what will be your code look like when you actually run it, which means that, for example, Terraform, like, you can compile the code and look at the plan that, hey, this is my intent, and whether this intent will translate into exact identical infrastructure. And we use a term called digital twin. Digital twin is nothing but representing your cloud as code in form of infrastructure as code. I know it's a little bit too complex verbose I'm using, but it's typically taking your infrastructure as and resources, define them in the code, and then run it through the pipeline as and when you need it, or update it through the pipeline as and when you need it. The benefits are, like I mentioned, one, it allows you to restrict the amount of changes that anyone can make in your runtime, which means that you are reducing your attack surface to your hackers or attackers who are trying to persist through configuration. So every time they make the changes, there are only minimal set of changes that our infrastructure team have to go through. The second piece is, when you go through the pipeline, you do certain kind of checks and analysis. So your infrastructure as code will go through infrastructure as code scanning, or it may be trying to deploy an application, so it can go to a SAST or test kind of application analysis. And also and also you can make certain decisions. And this is a decision tree is something we call policy guardrails. So when you have your infrastructure as code, you can create certain guardrails around your deployment that, hey, if I goes through any bad vulnerabilities, if my code has bad vulnerability, which will get reflected into the code, I would like to enforce a decision. And the decision is, do not create infrastructure. So either you burn secure or you do not burn at all. So those are the kind of security practice that you can apply, and it allows you to also become extremely agile and have a high velocity. So what is holding back adoption, in my opinion, is the architecture, because the teams are still on hybrid. There are companies, enterprises who are still using both kind of workloads, and mostly infrastructure as code is focusing on the control plane. But whereas the old workloads will require changes to the configuration of their workloads. Say, for example, hey, I want to upgrade my Apache 2.0. There is an infrastructure as code, but it just become more complex. So you might have to bring tools like Ansible, who's updating the software configuration or your service configuration. And then you have to bring in Terraform, who's deploying AWS compute storage and so on and so forth. And then you have to bring your container orchestration code like Manifest, Helm charts, and customize. So it's all about maturity. It's all about architecture, in my opinion, architecture maturity. As soon as the architecture maturity is there, teams will start doing infrastructure as code in just a matter of time.
Excellent. David, any thoughts on what else could be holding back adoption here?
I think those were all great points. I think the one thing that I would add is, first, we're just at the beginning of infrastructure really as code, right? And so, I mean, even like Kubernetes, we've used it within our own organization for all secure, right? And like figuring out how to do things like upgrades, it's really kind of a learned skill, right? Because Kubernetes itself is really more of this kind of like you move it off and then you destroy the old Kubernetes, you bring it up, right? Like there's a lot of kind of interesting paradigms that you have to come with. The second is, I think a lot of us, when we dive headfirst into these things, don't realize that you have to resource against it. So one of the hardest management lessons I learned is, like, if I hired a consultant, I kind of basically have to also hire or assign someone like a 10th of their time to manage that resource. You could never just say, oh, I'm going to the cloud and look at all these benefits of I'm going to outsource everything. You have to start internally resourcing it yourself. And I think that's something that people are just figuring out. And so you have to be able to find and hire the right talent, or within your own organization. I know education is a key thing. You have to figure out how to educate people about not just what are the benefits, but what are the nuts and bolts. I think just far too often we get really focused on what the end state is, and we read about an organization doing it and how successful they've been, but then we don't realize that that organization has already built the team that knows how to work with that sort of stuff, and it's appropriate for them. And maybe the way they deployed it isn't quite as appropriate as it is for you. So I think the big comment I would have is be gentle on yourself as you go forward on this. There's going to be some bumps and bruises. And, you know, when in doubt, double down on education as opposed to just getting yet another thing, another widget.
Yeah, that's a great point. It's anybody that's worked in this space long enough is full of bruises from just learning and banging their head against the wall. Jim, I know you've gone through the next section a lot in your organization, getting rid of snowflakes and centrally managing things and moving into config management as code, which is our next section. So I will pass that over to you to walk us through some of those stats and another question or two.
Sure, thanks, Eric. One of the things we wanted to take a look at was the runtime architectures that organizations are using, and there's a broad mix, no surprise. We're seeing about an equal balance between on-premise and cloud-hosted virtual machines. So this is a natural progression, right? You start to move into the first natural place to move from on-premises into a cloud-hosted virtual machine, and then progressively into other more sophisticated or powerful environments, right? Where you're offloading more of the responsibility onto the cloud service provider. And all of this, of course, builds on automation and automated resources. So again, we can see this is another sign of maturity. We specifically want to take a look at containers as a service. This is one area that was quite interesting. So Cloud managed container services continue to run a significant percentage of workloads. So we're talking almost 40% of workloads running in these types of environments. There's a lot of advantages to, again, moving from on-premise managed containers, right? You're running your own Kubernetes cluster is a pretty heavy lift for most organizations. And as David pointed out, skills aren't always available. So you have to learn as you go, and learning as you go means you end up making mistakes. So we understand that offloading some of this stuff and simplifying it a bit by moving it onto the cloud provider there's a lot of advantage to that, but there's still responsibilities that are important that you need to assume, making sure that you understand the security policies and defaults, right? So given the rapid adoption of container services, one of the questions we thought we wanted to explore was how can we see security teams gain more visibility into these environments? And David, let's get you to start looking at this one.
Well, I mean, I think one of the things to get security looking at this is first, you need to have a good understanding of what your architecture is, because a lot of security people have been trained in security and they have the appropriate mindset and skill, but you're going to have to teach them what this means and how to think about it. Because like there's the control plane for how you manage these services, and that's a different set of things than maybe the user is interacting through. And so understanding that sort of what the threat model is or how you're using it is a big important part of it. I think the second question is when you're talking about container services, you want to start investigating and understanding questions security are going to ask. For example, containers were really never meant as an isolation mechanism. If you go back and you look at what they are inside Linux, they're not actually intended to be a security tool. And so, when you're starting to get security involved, you're going to have to educate them as far as what you are doing and what you aren't doing and what lives where and what even a little bit of what the underlying infrastructure is, so that you can get so that security can get a fair handle on what the actual risk is. And so I think a lot of this also speaks to offloading some of it. I think the second part I'll add before turning it over to Piyush, who maybe has a lot of experience in this area, is we see people who are still having this on-premise, and I think there's actually still a lot of reason to have it on-premise. I know depending on your workload, it could be just more cost-effective to do so. We ourselves have a very compute-intensive workload, and using Google or Amazon is far, far more expensive than buying another 20K Dell box to run it on. And so I don't think in some ways there's things that are fundamentally different. As far as security, the big part is that you're going to have to educate security about what you're trying to do and how that architecture is, and then give them the time and space to learn about the environment. It kind of goes back to that learning.
Right. Yeah, that's right, David. I think the rapid adoption container services is a known fact now. I was going through a stat published by Airbnb. They made almost 125,000 code commits with regards to container infrastructure as code in last 1 year, which leads to the point that containers, because the containers are ephemeral, they come and go. You cannot live without automation. And the good part with them is whether you're running your Kubernetes or containers on-prem or on the cloud, you can still do the same kind of automation. So that's a good nuance there. There's no dependency on the public cloud. However, security team has a very limited access to that, and that's a very, very pertinent question that every security engineer should be asking. That how do I get the visibility? It is not always about operational visibility. The operational issues and security issues has a very thin line. So one configuration change could be operational in container world. By the time you realize that as a security change or security issue, the things have already happened. So security team must have tools that give them more greater visibility into configuration. And since the configurations are defined at the code, In most cases these days, the visibility can start from the left or the code. So it's a visibility. So it's a shift left or code visibility for security. And that's something I always insist that it's not just about the destination, it is about the source also. Your source is what going to define how your destination going to look like. So I think security team will require tools that will give them control plane level visibility and also data plane level visibility, which is what containers talking to each other, what changes are happening in these containers. Somebody has rebooted one of your pods as root privilege, and so on and so forth. So these are real problems, and security team needs to work closely with DevOps to deploy or purchase or acquire tools that give them that visibility, and not just the static, also the runtime. And this is the tricky part, that not all data that you can get from static in the container, you will have to rely on runtime as well.
I think when you touch on runtime, there's an interesting question as well as far as like container scanning and whether once a container is scanned, the security of that container is going to be, where that's going to sit. I think one of the challenges that we see, especially when you look at like Biden saying like, we need a BSOM, we need the list of materials on everything, is when you're doing container scanning, you get a ton of false positives. And I don't mean false positives like, hey, that library isn't out of date. I mean false positives like it doesn't actually affect the security posture. And so that's going to be something I think the security team is going to continue to wrestle with, which is also a question of how do we get those minimal images out there? And then how do we deal with the ongoing false positive? Because let's face it, right? If it's not on the attack surface, there's something to be said about not updating something if it's working. Every update introduces a code change, which can affect stability, which is another equally important business goal as security.
That's right.
And so I think this is kind of an area I feel we're a little bit, we don't really have great guidance and great techniques, because right now containers, it's kind of like just looking at your system and saying, hey, you should update something. But that's a running, living application inside that container, and you want it to be stable. And you wouldn't update your system every day or right before a big video conference like this one, right? So I don't know. It's kind of this really weird place that we're expecting developers. Oh, that's out of date. You should update. It should have happened yesterday. How come you're running out of date software? And it's like,
That's right.
well, I get paid when the stuff works, and that's kind of important to me. So it's a really weird place is all I'm saying for security when you actually get inside it, which is a little bit different than this question, which is talking about the orchestration frameworks. But I see Jim and Eric nodding their head. They must have gone through this themselves as well.
Oh yeah, absolutely. Yeah, I liked your point about upgrading before the video presentation. Windows wants me to put in the next fantastic annual or half semi-annual update. I'm not going to be doing that till after this video show is over, right? So it's a wonderful example. And you got to remember that security includes availability, right? So
Absolutely.
all right, Eric, let's get talking about continuous integration and delivery.
Yeah, that's actually kind of where my head went when we talked about availability and patching. A colleague of mine, I remember, mentioned back at, I think, Loco Moco Sec back in, it's been a few years now, but it was that concept of continuous patching, dealing with some of those libraries that may or may not be on the attack surface, but if we want those scan findings to go away and keep availability, really the only way that you're going to be able to do that is by getting very, very high test coverage in CI/CD pipelines to know if I patch this low-level library and if I've got, high 90 test coverage on this system and it makes it through my dev and my, kind of automated acceptance testing, you should be relatively assured, we'll say, that thing is actually going to run if you put that into production. So it's kind of one of those key concepts of DevOps, is that continuous experimentation, but also controlled deployments into production, knowing that it should work without affecting anything, or you should at least find out very early So we've been asking CI/CD questions now for a few years, looking at kind of agile and core DevOps practices across a lot of these organizations. And the numbers are probably lower than I would like to see them, but everybody's on their own journey. And obviously in an enterprise, it's a lot harder to go from system administrators manually making changes on production servers from the command line and copying packages around to get over to fully automated CI, where that's all of your testing. And it looks like we've got automated builds and automated testing, 66%, 52%. So room for improvement there to achieve, what David described, which is how do I know if I touch this library that it's not going to break anything? And if you don't have those two things working correctly, it's just not going to happen. So a little bit of room to improve there. Jim and I, for a couple of years, have also been looking at, well, what are we using to orchestrate, the CI/CD process? And this has been a pretty hard shift over the last couple of years where, forever Jenkins was the tool, and as John Stevens said in a keynote at a summit last year is, Jenkins ruled the last 10 years in CI/CD. And you've seen the newcomers over the last couple of years, which is kind of cloud managed CI/CD solutions that very tightly integrate into your version control system. Just when I commit code, I don't need another tool. I don't have to babysit Jenkins on an internal server. I don't have to patch its plugins. I don't have to harden the network it's sitting on, etc. It's just when I commit code to GitHub or GitLab, they've now got integrated actions and CI/CD workflow files that are YAML created that just say, here's all the different commands that I need you to run in order to go test and deploy this thing. This adoption has flipped from last year. Last year we saw Jenkins up there right around 55, and we saw GitHub, GitLab down in the, mid to high 40s. And just in this year, we've seen GitHub and GitLab kind of take the lead there. So it's a pretty big increase from last year. And I think it speaks to people wanting to deliver things, not maintain and build the CI/CD server. So a little bit of that responsibility model shift. So we take a look at the next question. What I was very interested in, your thoughts were related to supply chain security for software or even cloud infrastructure code. It could be anything. You've seen with SolarWinds, you've seen with the CodeCov breaches that, affected HashiCorp themselves and some of their signing certificates. You've seen people targeting the deployment infrastructure, whether it's version control or CI/CD, to put some backdoors into systems. What do you think as far as defending this? Is this a fundamentally unique challenge, something net new to security? How would you start about tackling this? Payush, why don't we go ahead and start with you? What are your thoughts on the software supply chain issue we're seeing?
Right, and yeah, it's a brilliant question, Eric. It's a very, very critical question given what we just discussed. So once I'm just taking again a step back. You have a pretty modern cloud native infrastructure architecture. You have a good cloud automation. You have CI/CD pipeline. The next thing is going to happen is supply chain, which means that the way industry is shifting left, the attackers or the hackers are also moving to the left. They're going to leverage more and more your infrastructure vulnerabilities, and not so talking the architecture infrastructure. I'm talking about your development infrastructure, your CI/CD infrastructure, your Jenkins Groovy scripts, or your build specs, because that's where they will embed their piece of product, right? Like back in days in endpoint world, they used phishing or email phishing, where they embed their malicious code into a binary or through a medium and inject into your app into your devices, and then go lateral movement. The same thing is happening here. The same thing happened in SolarWinds. Same thing happened in the power plant attack. So your infrastructure so your application is secure. You have started to do more security on the left, but now your actual infrastructure on which on which your CI/CD or your your development is working is going to be vulnerable. So and there are instances where the code configuration was changed in the source code repository, your deployment configuration was changed and the wrong binaries or the malicious binaries were injected, and there was no attestation happened at that stage, because by the time your image was downloaded, your build was created, your system assumed everything is good because my DTR is, my ECR is completely secured. So, and that is why this is going to be a pretty significant challenge, in my opinion, in next year or two. So it's a unique challenge, in my opinion, just to summarize. It's a pretty unique challenge. I think that, again, it's a fundamental change of thought process also. We have not, we are not used to this kind of attack or this kind of practices, but the history is repeating itself.
Yeah, I think we're all in the process of learning from this a little bit. David, what are your thoughts on maybe how we can address this or where we're sitting right now?
Well, what's kind of interesting about this is it's just the next logical step in extending your TCB to being someone else's problem. I mean, that's really what software as a service is, right? Is my trusted computing base is someone else's problem. So when we put everything on GitHub, yeah, someone could break into GitHub. Also GitHub's a pretty big organization. For all we know, they're hiring, there's going to be people just statistically in GitHub that are not necessarily ethical, right? That's just the law of math, statistics. What I actually took away from that statistic was a little bit different. I think what I'm seeing is a lot of hybrid scenarios where people are keeping core code still on locally hosted infrastructure, and then they're adding things like GitHub. For example, companies, there's this huge rise of APIs, and everyone publishes an SDK for how to interact with their APIs. And so I think some of this rise is actually tied maybe to a root cause where companies are starting to publish code as the way you interact with a company. And so I don't know that this statistic bears it out yet, but I think going back, you could select multiple. Those numbers didn't add up to 100. So I'm seeing people doing one of each. So I think the supply chain and where you want to trust is an important issue. And then I think you want to look at what are you trying to share? Like, are you just trying to offload all your CI/CD development? That's one scenario, and you're going to have to reason through that quite differently than, hey, we want to make sure our SDK is out there and open source because that's part of our business model. That's a much different risk model. And so I think what we're seeing is people like to move there, but I think what security needs to do is stop and ask, like, what are we moving there? Why are we moving it? And is that the appropriate location for that sort of thing that we're gonna do? I think that's just kind of my high level comment on that. That being said, I mean, these are wonderful architectures. Like you said, you get all the benefit of cloud, and it kind of really helps for when you don't have anything specialized that you want to do. You want to kind of just follow best practices.
Right. Yeah, it's interesting. You mentioned kind of the almost threat modeling your applications in a sense to see what might fit in the cloud hosted model versus maybe what you need to keep closer to the vest on-prem. I think that's a good kind of takeaway point there, really for anything that we're putting in the cloud. So I think we've got one section left here. Oh, sorry, go ahead, David.
Yeah, and I think like security has to work hand in hand with legal as well. This is something people don't think about a lot, but when you you're entering into a service level agreement with GitHub. And again, it goes back to industries, right? Like if you work in automotive or aerospace and you have ITAR restricted stuff, you're just not going to be putting it on GitHub because you can't.
Right.
And so always good to get legal also involved in these questions.
That's a great point.
Yeah, good stuff, guys. Thank you. All right, so the last thing we wanted to take a look at in this survey was essentially, what does it mean to organizations moving forward? What are the challenges and success factors that they need to look at? So what we found in the last few surveys is staying consistent, is that there's a lot of concern, especially in the technology space, about how good the technology is and about issues like false positives and everything, which are very valid. But what we're seeing is that again, if tools get better and faster, that is going to make everything much better, right? But what we're seeing is that the major challenges and success factors are still organizational. That hasn't changed in years. We've been surveying organizations for a while. So we're still talking about organizational silos, lack of budget, shortage of skills and security training. And as the velocity increases, we're also seeing the continuously changing requirements and priorities. So what ends up happening is that these teams, as they become more agile, the delivery teams, they start moving and changing faster, pivoting. This is all great for the business, right? You can fail fast, you can move forward and experiment. But what that means to a security organization is just a constant state of, I'm not saying panic, but concern, right? As priorities and goals and products and architectures change and people move forward, right? And the cloud architecture, being able to offload concerns onto the cloud, is just making this even easier for development organizations and more challenging for security. The success factors that we've seen, some of the top success factors are around training and education, just bringing people up on cloud and DevOps concepts. And this is not just the engineers themselves, but also the security team. Improving communications across disciplines and securing buy-in from managers and developers. So part of this is the whole DevOps and Agile, goals or programs that are in place to try to improve communications and break down walls. And part of this is just the fundamental inertia within these organizations that needs to be overcome. So we wanted to get your ideas, guys, about what does this mean about cultural changes within secure DevOps? So does this imply that organizations need to make cultural changes before trying to implement a more secure, modern security program, or can a successful DevSecOps initiative be the catalyst for a successful implementation? So we wanted to ask you, David, for your ideas first.
Well, I mean, I think when you see a spark inside of something that's going to be changing your organization, you certainly want to fan the flames for something around DevSecOps. That's assuming that there's a spark, right? And it's something that's going to take your organization the right way. I also know you have to be a little bit careful because it can backfire. For example, someone can say, hey, we should move to Kubernetes. But if you don't actually have the organizational support to manage and understand what that means, you could actually be shooting yourself in a foot. So you want to be kind of carefully balance a little bit the idea that a single initiative is going to change the company, because it could be buying into things that the organization just isn't prepared to handle. I think really I see this as kind of two tiers of different things to tackle. The first one is just, how do you go about affecting the change in the first place? And one thing that I've seen that works pretty well is you surge. You plan a time where you say, hey, we're just going to pour an inordinate amount of resources in making sure this is successful, knowing that we're going to back off. And this is just a key to any change. Trying to, slowly inject it at the high speed of technology is going to be really hard to do, because by the time you're onto Kubernetes, we have K8 now, there'll be K12 by the time you get done, whatever K12 is. Kubernetes with something after it. So I think I'm a big fan that organizations should be trying to enact that cultural change and actually try to surge. And then you want to find those pockets where people are doing it, but you also want to be careful that they're not going to be causing something to burn to the ground. Because I've actually seen that happen too. People say we should do something, and they don't really appreciate that. The second part that you get at is really the workforce problem. In many ways, all of security is a workforce problem. If developers had all the time they wanted, I think that they would say, hey, all those bugs wouldn't happen, or there'd be far fewer. And so the idea of building an education, I think, is a huge part of it as well, where you want to set aside some time in the day or some process where people can bring up-to-dates and then pick out parts where they can adopt that. I found this like a very interesting part overall. One of the more interesting parts of the overall paper because pretty close to the top was just integrating, going back to your very first question about integrating testing. I think the question is, where do you start? And I think one place to start is to integrate actually your continuous testing. A lot of security people want to start by, okay, I got to get security in. I got to get this, one thing in for security, and then I'll be better. But, it's not more secure until it's fielded. And the barrier for security is, has it been tested well enough that we can actually field it? And so I would recommend people start there. And again, that's kind of why we're a little bit in love with things like fuzzing or dynamic analysis, or even DAST if you don't want to be that, as kind of a first step, because there it helps you automatically build up a test suite. You have zero false positives. You don't have to deal with those more sophisticated issues that you might have to deal with otherwise. And it just requires less education. So that's kind of my take on this question. I'd be really interested if other people in the audience or the panelists have different opinions.
Well, I like your point about testing and test automation, because part of this is to start creating those feedback cycles, get people, get the teams involved and engaged, and again, get the plumbing and wiring all in place for this kind of thing, right? So once you've initiated some automated testing, you can initiate more automated testing and scanning, and it starts to create it creates a level of acceptance, and I certainly have had that experience in my own organization. Piyush, what would you like to say about this?
Yeah, so I think, in my opinion, there's no single bullet. I think, like David also alluded on the point that it's not just about adopting new technology, it's also about changing the mindset, changing the practices. I was just trying to articulate in a different way. I'm just saying that, hey, if you're moving toward becoming a modern organization, you need to take a step back and start thinking three things primarily. One, your organization, that who you are, what your DNA has been. Second is your application architecture, means what kind of applications you have, what kind of customer base you have, what kind of user base you have. So sometimes adopting technology is also about a factor of who is using your product, how they're using it, so on and so forth. And third and most important is understanding the architecture also. So whatever architecture you have, you need to start from there, which is building some threat models, drawing some topologies, understanding your entire surface, and on top of that, you can find out, when you draw those models, you can find out that which part you want to harden more, where you need to invest in hardness, where you do not have to. In my opinion, continuous testing is no-brainer. It must happen, and it should happen whether you are an application or you're an infrastructure team. So whether it's infrastructure as code or application, continuous testing is the only prevention that you have, right? So it has to happen. Second thing, in the cloud world, there is no protection or there's no prevention. How do you prevent? Is you detect early and you remediate early. Means you test continuously as early as you can, you find issues early, and you remediate early. So that's in my opinion are the two fundamental things. One, you understand your architecture, you understand your skill set, your organization, and understand your application well, or architecture, not just application, the architecture, the entire infrastructure. So once you have that, you draw the threat models, and then you start detecting by doing continuous testing, then you remediate, and also eventually you start contextualizing your threats or your alerts onto a bigger spectrum, which is something we call breach path prediction, right? So once you have all these right controls in place, how do you start creating more meaningful data out of it? Is going to be more contextualization of different threats coming from different places. So it's a maturity model, in my opinion, should be drawn around this.
I also want to say, I think you're totally right. I think I want to add one more thing to testing that I think we'd all agree. And it doesn't get said explicitly enough. There's actually two types of testing you should be doing. There's what's called positive testing, which means do things work the way you expected, right? Like I expect this app to be able to take this HTTP request and process this return. That's positive testing. Did it do the good things I expect it to? As part of adding in continuous testing, I would also add in some form, or at least the concept to your team, of negative testing. Negative testing is saying, did something bad happen? Like it shouldn't do something. And that a lot of security has to do with the attacker finding not just, hey, the good things continued to work. It's not like, they gave you the valid HTTP request and they owned you. They did something unexpected. And so it's this idea of negative testing. So when you go into continuous testing, you need to actually be thoughtful of how do I automate it? And then also like I'm automating both positive testing, which is actually pretty common for developers to think about. They know they've been writing unit tests, or at least they've been exposed to it. But also this idea of negative testing. And that's often where people get hung up. And that's where security can help with the education of developers. Developers have to educate securities to the architecture, but security can like educate and like, well, have you ever thought of this? Like, what if this goes wrong? That's kind of something I thought would be really important to be explicit in this webinar, because it's far too often we just assume everyone knows that you should do both. But yes. It's good to be explicit rather than implicit. Take a Pythonism.
Yeah. Oh, very good points. Very good points. Yeah, you learn that early as a developer when you give it to a user and they press the wrong button and the program blows up and you just stare at it and wonder why. Yeah. We have just a few questions. Carol, do we have enough time to go through some questions from the audience, or?
Yeah. Thanks for that great presentation. We do have some questions ready, so I'll jump in and get started. The first one asks, would it be a chicken or the egg situation? Infrastructure as code needs to be adopted, but to be adopted, people want to see IAC use first.
Let me take that one. Can you hear me?
Yeah, Piyush, this is great for you.
Okay, so somehow I thought I lost my connection. Yep, so it is not, and you have to start small. You do not have to boil the ocean by bringing all multiple different kind of infrastructure as code. Keep it something that starts with your platform and then get to the application. That way you always, it's a bottoms up approach that you must take, and not bring in all kind of permutation combination that you can use. So infrastructure as code should start first, in my opinion, but that completely depends on your application, your architecture, and what you're actually creating, or what you actually need as resources.
All right, thanks. We'll squeeze one last one in. What sort of choice in tools do you make when you want high DevSecOps automation?
David, you want to take this one?
Well, I mean, I have a very strong opinion because I even, I did 20 years of research at CMU, won the Cyber Grand Challenge, and then made a company. So I'm a big believer in fuzzing for DevSecOps for high automation because it grows your test suite, performs negative testing, and has zero false positives. People would say the negative of it is it's not a scan that's like, analyzing each line of code, but it is making sure that what's tested is really tested well. So that's the first tool choice I would use. The second is I would definitely go to containerization when possible. And I want to acknowledge not every industry can, especially people who are doing IoT or OT where there's some crazy device they have to run on. But just the idea of like automated build, like a lot of what we say doesn't really work unless you do that. And then I think those are kind of the key ones. There's going to be a lot of language dependent variables as far as how you do testing. Like how you do it in C, C++, or Go or Rust is going to be different than how you do it in Python or JavaScript. And so you want to look at what the best practices are there. So I think those are kind of the biggest ones. I think finally, when you're trying to build high speed, one of the things that you need to measure, and I've seen this go wrong, is the debug loop for your developers. If it actually takes your developer a full deploy to figure out there's a bug, that's a problem. And so spending enough time to have, so your testing infrastructure can be locally reproducible, at least up to the kind of single component level, or single app level, I think is huge. Because I've seen some DevSecOps that really get slowed down by, they have these really sophisticated testing that maybe even run overnight before they can deploy, and it's very thorough. But then basically, we're kind of back to the 1980s where you press compile and come back in the morning and see if it worked. And so try to get to the point where a lot of the key tests can be done locally. And that would be a criteria that I look for in the tooling.
All right, well, that's all the time we have for today. Thank you so much, Jim, Eric, David, and Piyush for your great presentation, and to Accurix and For All Secure for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.